Hello and welcome to another video on memory and storage. Today we're on to lesson 10 of the series. This is a very big unit.
That's what she said.
But we're on to lesson number 10 today, and that's going to be all about compression. What do we need to know about compression? Well, we need to know why we need compression, and we need to know about lossy and lossless compression and describe them in a reasonable amount of detail for our exam. As we should have realized from previous lessons, storing images and sound can lead to very large file sizes. This can be a problem for sending data across the internet or saving data onto devices with limited storage. For example, mobile devices like smartphones or tablets. Compression reduces file sizes. This is to reduce download times, make the best use of available bandwidth on a network, and to reduce file storage requirements. Data compression involves trade-offs. We have the quality of the final result, and we also have to think about the amount of processing power that is needed to compress and decompress the data. There are two main strategies to reduce file sizes: lossy compression or lossless compression. Lossy compression is a way of reducing a file size by removing some of the data. As it is removed, the original cannot be recreated from the compressed file. Considerable savings can be made with lossy methods, but the issue of quality has to be recognized. Typically, audio files are often reduced by a factor of 10 to 1. That means a 10 megabyte file could be reduced to as much as 1 megabyte. Photographs are also reduced by a ratio of approximately 10 to 1. Videos can be compressed a great deal before the loss of quality becomes unacceptable. Often a 100 to 1 ratio is common, so a 100 megabyte file might be reduced to as much as 1 megabyte using lossy compression. Some key points about lossy compression are that we are removing some of the data. This makes considerable space savings, but once the data is gone, it cannot be recovered. This is often used for media like sound, images, and video files. Situations where a minor loss of quality might not be noticeable to the person viewing the file or listening to the file. The idea is to remove the data that is the least important. Human senses are fairly fault tolerant, unlike computers. So for example, with MP3 audio files, one of the techniques to reduce file sizes and compress the data is to remove the frequencies that humans cannot hear. So you can remove some of the higher frequencies and the lower frequencies from the original recording that aren't detectable by human ears, and we can reduce the file size with no loss of quality. In images, large blocks of very similar colored pixels are combined into one block of the same color, so the image still looks very similar to the original. You can see that there's some loss of detail in the second image here, but the essential features of the image are still clearly visible. So the uncompressed photo is a little bit better than the compressed, but unless we're zooming in, unless we're studying the detail very closely, the compressed image will be acceptable in many situations. So for example, sharing on social media. Again, I'm going to repeat this. It is important to note that once a file has been compressed using lossy compression techniques, it cannot be reversed and restored to its original condition. So once I throw that data away, I can't then go back and restore the original. Once the data is gone, it's gone. Moving on to lossless compression. For some files, losing any information is simply not possible. For example, losing some characters or words in a text document would make that document very difficult to read. Computer programs, for example, won't work at all if some of the instructions are removed. Lossless compression is when we reduce file sizes in such a way that no data is lost and the original can be regenerated exactly. This makes use of redundant or repeated data, so that if a data item recurs multiple times, the item is stored along with the number of repetitions. For an example of that, let's consider the following sentence. If you are not fired with enthusiasm, you will be fired with enthusiasm. The original text here is 70 characters. We're not going to worry about capital letters or punctuation in this simple example. It's just a little illustration of how lossless compression works. Let's build a list of unique words in the text. So there are 9 unique words, and we can say, all right, if is going to be represented by the number 1, you is going to be represented by the number 2, and so on and so forth for all 9 words. Now we can store the text as 1, 2, 3, 4, 5, 6, 7, 2, 8, 9, 5, 6, 7. The new amount of text we have to store is 36 characters for the dictionary in the previous slide, 26 characters from that list that you can see here, including the spaces, of course. And that gives us a total of 62 characters versus 70 in the original. This is a reduction of approximately 11%. This technique is known as dictionary coding. And while it's not effective as, say, lossy compression, remember we're not losing any of the data. We can restore that sentence exactly using our list. Of course, for larger blocks of text with many repeated words, this can reduce the size of a text file quite considerably. In summary, when transmitting files, storing very large files, or storing a large number of files, we need to compress the data to make it smaller. We have lossy compression, where some of the data is removed to make the file smaller, and lossless compression. None of the data is removed. Instead, algorithms look for patterns of repeated data. I hope that was useful to you. Have a very good day, and I'll see you in the next lesson. Goodbye.